In this video, we're going to learn about quartiles and interquartile range. Quartiles and interquartile range are both metrics on a dataset, and we already know a few metrics on a dataset. So let's briefly review those few metrics that we know so that we can set the stage to introduce quartiles and interquartile range. First of all, there's the minimum. The minimum is the value such that 0% of the other values are below this value and 100% of the other values are above this value. And if the dataset is sorted from least to greatest, then of course the minimum is just the first value of the dataset. Likewise, there's also the maximum. The maximum is the value such that 100% of the other values are below this value and 0% of the other values are above this value. And if we've got a dataset sorted from least to greatest, then the maximum is the last value in the dataset. So if there are n values in the dataset, then the maximum is the nth value, the last value. The median of the dataset is the value such that 50% of the remaining values are below this value and the other 50% of remaining values are above this value. And for a dataset sorted from least to greatest consisting of n values, this is how we compute median. If n over 2 is whole, then we just take the n over 2th value, whereas if n over 2 is fractional, then we average the surrounding values. Alright, now we're ready to introduce quartiles. We'll start with the first quartile. Which is also denoted as Q1. The first quartile is the value such that 25% of the remaining values are below and the other 75% of remaining values are above. So really, the first quartile just splits the dataset at a fourth of the dataset, or a quarter of a dataset. And here's how we compute the first quartile. If n over 4 is whole, average the n over 4 and n over 4 plus 1 values. On the other hand, if n over 4 is fractional, then round up to the nearest whole number. Let me point out that we're rounding up, never down. Always round up to the nearest whole number. So even if n over 4 is like 2.25, you still round up to 3. Okay, so that's the first quartile. There's also the third quartile, also known as Q3. This quartile separates the dataset such that 75% of the remaining values are below the third quartile, whereas 25% of the remaining values are above. And the way we compute this is very similar to the computation for the first quartile, except now we use 3n over 4. So if 3n over 4 is whole, average the 3n over 4 and 3n over 4 plus 1 values. Otherwise, if 3n over 4 is fractional, then round up to the nearest whole number. So the quartiles really fall in naturally to the metrics we already know on datasets. The first quartile just splits the dataset at a fourth of the data, whereas the third quartile just splits the dataset at 3/4 of the data. So in the context of quartiles, the median can also be thought of as the second quartile. because it splits at 2/4 of the data, or half of the data, 50% of the data. The minimum is like the 0th quartile, because it splits the data at 0/4 of the data, 0% below, 0/4. And then the maximum can be thought of as the 4th quartile, because it splits the data at 4/4, or 100%. Alright, so before we go on, we have one more thing to discuss. That's the interquartile range. Recall that the range of a data set is just the maximum minus the minimum. Let's write that down. Range equals maximum minus minimum. It's just the distance from the minimum value to the maximum value. And likewise, the interquartile range is just the distance from the first quartile to the third quartile. So interquartile range, also known as IQR, interquartile range, is equal to the first quartile also known as Q1 minus the third quartile, also known as Q3. So there we go. That's how the first quartile, third quartile, and interquartile range are defined. And now that we know this, let's go ahead and work some practice problems. Here's our first problem. Find the first quartile, Q1, the third quartile, Q3, and the interquartile range, Q3 minus Q1, of the dataset below. 1, 5, 9, 7, 6, 9, 1, 10. Alright, so first of all, the very first thing to do here, before we can begin picking out the first and third quartiles, the dataset needs to be ordered from least to greatest. So let's go ahead and do that. So what is the lowest number we see in the dataset? It looks like 1. So let's go ahead and put 1 down as our first entry. We'll check off that 1, so we know that we've already included it. Are there any other ones? Yeah, right there. So 1, 1, check off that one. Okay, what's next? Are there any 2s, any 3s, any 4s, any 5s? Hey, there's a 5. So let's take that 5, check it off. Any other 5s? No. Any 6s? Yeah, right there. So let's take that 6. Any other 6s? No. Any 7s? Yeah, right there. There's a 7. How about any 8s? No. 9s? Yeah, we've got 2 here. 9, 9. And then the last entry is 10. Okay, so now we've got our ordered data set, and how many values are in the data set? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8 for this data set. Alright, so first thing, we want to compute the first quartile. So we have to take n over 4 and see what that is. So n is 8, n over 4 is 8 over 4, which is 2. Now since 2 is whole, we want to average the second and third values. Okay, so let's see what the second and third values are. So I want to compute the average of, what is the second value? Well, first value is 1, second value is also 1. So average of 1, and what is the third value? Well, that's the value right after 5. So we want to take the average of 1 and 5, and we do that by just summing them and dividing by 2. So 1 plus 5 over 2 equals 6 over 2, which is equal to 3. So that means that the first quartile, Q1, is equal to 3. Alright, and then how about the third quartile? The third quartile is really similar, except instead of using n over 4, we use 3n over 4. So 3n over 4 is equal to 3 times 8 over 4, and it's just 8. 3 times 8 is 24, so 24 over 4 24 over 4 is 6. And then since 6 is whole, we want to average the 6th and 7th values. So we want to compute the average of, what is the 6th value? Let's check. 1, 2, 3, 4, 5, 6. Average of 9. And what is the value after that, the 7th value? Also 9. Average of 9 and 9, so let's go ahead and compute that. You just add them, 9 plus 9, and divide by 2. It's equal to 18 over 2, which is equal to 9. Yeah, that's no surprise. Average of 9 and 9 is 9, of course. And then Q3, the third quartile, then, has to be 9. Okay, so now we can go ahead and compute the interquartile range. Interquartile range, IQR, is equal to Q3, third quartile, minus Q1, the first quartile. So just subbing in our information, IQR, interquartile range, is equal to Q3 is 9, so 9 minus, and then Q1 is 3. So interquartile range is 9 minus 3, which is 6. So there we go, we're done. Here's another problem. We want to find the first quartile, the third quartile, and the interquartile range, Q3 minus Q1, of the data set below. 0.2, 0.75, and so on all the way down to 0. Remember that our first step is always to sort the data set from least to greatest. So let's go ahead and do that. What is the least value we see in this data set? Why don't we keep track as we run through it? 0.2 is the lowest, and then 0.05 is even lower. Anything lower than 0.05? 0. Anything lower than 0? No, 0 is the lowest. So let's go ahead and put that first. 0. So let's cross off dot 0. And then any other zeros? Yeah, there's one over there. So 0 and then another 0. Okay, what's next? I think 0.05 was the next lowest value we saw. Let's just scan through, make sure. Yeah, nothing bigger than 0.05. So 0.05 will be next. And then what comes after that? Is it 0.2? Is there anything lower than 0.2? Oh yeah, there is. There's 0.1. So let's put that down, 0.1. And then we can put down our 0.2. And any other, there's another 0.2. It's another 0.2. Any other 0.2s? No, okay. Anything bigger than 0.2? There's 0.75. That doesn't seem right though. 0.3. That looks like the next one. 0.3. Any other 0.3s? No. How about any 0.4, 0.5? Hey, there's a 0.5. And there's another 0.5 right over here. Any 0.6, 0.7, well there's a 0.75. Any 0.8? Yeah, there it is. There's two of them, 0.8 and 0.8. And then our last number is 1. Okay, yeah, great. So now it's sorted from least to greatest, and we can finally begin computing the first, third quartiles and the interquartile range. First, let's count up the number of values in the dataset. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So n equals 13. And now we can begin with our quartile computations. So first quartile, we want to compute n over 4 to start with. N over 4, well n is 13, so that's 13 over 4. And 13 over 4 is equal to 3.25. Now, because that result, because 3.25 is fractional, it's decimal, it's not a whole number, we want to round up to the nearest whole number. So round up from 3.25, so round to 4. So Q1 equals the fourth value. And now let's just go ahead and find the fourth value. So Q1 equals, what is the fourth value? Well, 1, 2, 3, 4. 0.1. So there you go. That is the first quartile, 0.1. All right, next up, the third quartile. It's the same kind of reasoning, but now we have 3n over 4. And 3n over 4 is equal to 3 times 13 over 4. 3 times 13 is 39, so we've got 39 over 4, which is equal to 9.75. And again, 9.75 is fractional. It's not a whole number, so to get Q3 we need to round up to the next whole number. So Q3 is the 10th value. And let's go ahead and find that 10th value. So Q3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Q3 is 0.75. So there we go. There is the third quartile. And now how about the interquartile range? Interquartile range is Q3 minus Q1. So just substituting in the values. Interquartile range, Q3 is 0.75. Q1 is 0.1. So interquartile range is equal to 0.75 minus 0.1, which is just 0.65. So there we go. There's our interquartile range. So now we know how to compute quartiles and interquartile range on a dataset. And in the future, we'll learn more ways of picking out information from datasets, such as representing them visually as box plots or distributions.